This is lesson 8.3. We'll be talking today about the area of a triangle and how to calculate the area of a triangle, and we will be learning about the law of sines. So before we get into that, we need to talk a little bit about conventions. Conventions are the way in which something is usually done, or when people sort of all agree to do something a certain way. In math, one of the conventions that we use with triangles is that when we're going to label our triangles, we want to label the angles with capital letters. Really, it's because these capital letters are representing the points at each of the vertices of the triangle. So we label those with capital letters. It doesn't have to be ABC, but this just shows you with ABC. If it's a right triangle and you're using ABC, C is typically reserved for the right angle. And then the side across from each angle is labeled with the same letter, but we use the lowercase. So we have angle B in the triangle. Across from that would be the side that's labeled with a lowercase b. You have angle A in the triangle here, and the side that's labeled with an A will be across from that. And then in this case, we have our last angle labeled with a C, and the side across from it would be side C. So if we use these conventions, sometimes if we don't have a diagram, we can just talk about what the sides are and use these conventions to build our own triangle. So if you have a triangle and you want to find the area of a triangle, in the past you should have used a little formula to help you find the area of a triangle. And what you probably have done in the past is used the height of the triangle. And you're probably familiar with the formula that a triangle is 1/2 the base times the height, and that's the area of the triangle. Wow, I'm spelling area with an H now. That's great. So for this triangle, it would be 1/2 of, I purposefully turned it so that the B would stand for base and the height. But what if we don't know the height of the triangle? Well, we are going to do a little proof now of what that area could be if we don't directly know the height. I have the height drawn in here because for a minute I want to focus on just this little part of the triangle. And if we draw the height in the triangle, it creates a little right triangle. So what I want to think about is how could we come up with a formula for the height using the right triangle? Well, we've been talking about right triangle trigonometry, and we have this angle here, angle A. And we've been talking about what's the sine of angle A, what's the cosine of angle A, what's the tangent of angle A. So let's think about our right triangle for just a second. We have an angle A right here, and across from that, the height is the opposite side of that little red, yellow right triangle. And I know some of you use H for hypotenuse, so be careful here that our H is representing height. And then in that same little right triangle, if this is our angle A here in the corner, the C that we have here would be the hypotenuse of that right triangle. So we could set up a little sine equation. Our equation would look like the sine of angle A is equal to the opposite side, which is H, over the hypotenuse, which is C. Now, if the thing that we're kind of wanting to think about right now is this height, we could solve for the height of the triangle. And if we wanted to get that H, that height by itself, we would just multiply both sides of our equation by C. And these two would reduce. And we'd be left with the formula C times the sine of angle A is equal to H, or the height. Well, if we want to think back again about the area of the triangle, we could use this relationship, and everywhere we see an h or a height in the area formula, we could put c sine A because they are equal to each other. So going back over here to our area formula, the area is 1/2 of the base times the height. Well, 1/2 of the base times by, if we use this equation over here for height, we're going to put in our formula c times the sine of A. So the area is 1/2 of BC sine A. Well, if you look at the triangle, that's kind of interesting because that's saying we can directly calculate the area by multiplying 1/2 times the side that is, in this case, B, the base, and multiply that by this other side over here, C, and then multiply that by the sine of the angle in between. That's the area formula for a triangle. Now we could have turned our triangle the other way, and we could have done the same thing from the perspective of one of the other angles. So it really could be any of the two sides in the formula. It has to always be, though, the angle in between. For example, if I'm thinking about side C, or if I know, sorry, angle C, if I know angle C, to calculate the area, I use side A and side B. So it would be 1/2 of those two sides multiplied by the sine of angle C. We call it the included angle. It's the two sides that we're using and the angle that's included between them. If I was thinking about, or I knew angle B up here, I could calculate the area using sides C and A. Always, whichever angle you're using has to be between the two sides that you're using. Again, called the included angle. So let's see if we can calculate the area of a triangle. Find the area of the triangle with sides 11, 5, and 6.5, and angle C in the triangle is 20 degrees. Now it doesn't give us a picture, we can draw one. You can try to draw it to scale if you want, but as long as you get, sort of roughly the right idea, I'm going to call that 11, 5, and 6.5. Now this one was C, 5 was B, and A was 11. The angle that it tells me is angle C, and so our convention says that needs to go across from side C. It's going to be this one over here. The other angles would be A and B here. So if I want to know the area, I'm going to use the area formula, 1/2. And then we multiply two sides together by the sine of the angle in between. Because of our setup, the only angle we know is angle C, so we're just going to use side B and side A. We won't use side C at all for this problem because the angle that we know is between side A and side B. So it'll be 1/2 of 11 times 5 times the sine of 20 degrees. That's going to give us the area. So if we calculate that, gotta grab my calculator. We get that the area of the triangle is 9.4 units squared. The area formula is not super difficult to use, so I'm just going to do that one example. Again, as you're doing your homework, if you're not sure how to do it or not sure which sites to use, just talk to your teacher. It's usually people get it. So if you do still struggle with it, though, please talk to us because you'll get it. It won't take you too long. Maybe you just need one or more example to look through. So we're going to switch now to the law of sines. It's a lot bigger idea for us today. The the law of sines is right here on the screen. If triangle ABC has sides that are length A, B, and C, as shown in the diagram, then we have this relationship that the sine of angle A divided by A is equal to the sine of angle B divided by B, and that's also equal to the sine of angle C divided by C. It's just saying that the sines of the angles and their side lengths are proportionate to each other. And if you did the reciprocal of all of those little fractions, it would also be true. You could take side A and divide it by the sine of angle A, and that would be equal to side B divided by the sine of angle B, and that would be equal to side C divided by the sine of angle C. And remember, our convention is that capital letters are standing for angles, and in the law of sines, those are always inside of a sine function. And those lowercase letters are always standing for the lengths of the sides in the triangle. Now this equation has 3 parts, but that doesn't mean we're using all 3 parts at the same time. You would only just use 2 parts of the equation depending on what you're doing. You just pick the 2 that you need, or the 2 parts that you need to help you solve the problem. For example, if in my triangle I knew angle C, and I knew side C, and I knew side B, and my goal was to find angle B, I would probably use those 2. And I would just ignore the part with the A. So, we'll go through a few examples here, and you'll get used to how to pick, which parts of the formula you want to use. But you do just use 2 parts at a time as you're using that to help find different parts of the triangle. So this first one we're going to do is calculating side lengths. So it says for the triangle shown, find the length of sides A and side C. And as we look at this triangle, you might notice that also does not indicate the measure of angle B. So we're going to actually find that very first. Anytime you look at a triangle and you can see 2 of the angles in the triangle, remember that we have the rule with triangles that the 3 angles must add up to 180 degrees. So we can calculate angle B by just taking 180 degrees and subtracting the 2 angles that we know. And when we do that, we find that angle B is equal to 40 degrees. So we're going to add that to our diagram. We know that angle B is 40 degrees. So we are going to now find the length of the side that is marked with an A. Well, in this triangle, and always when you're using the law of sines, you want to look for an angle and a pair that are across from each other, like partnership here. We know angle B is 40, and this 24 length up here is side B. I know that it's side B because it's across from angle B. So we know all about the B's, and we're going to use that to help us find side A. So when I set up my equation, I usually put the thing that I'm looking for first. I'm looking for side A this time. That was my goal, to find side A. So in the law of sines, the sides and the angles always go in the same fraction. And so I'm going to put angle A inside of a sine function on the bottom. A over sine A. And you can look at your formulas on your notes to see sort of what this law of sines looks like. And then since we know what side B and angle B are, we're going to use that to help us. And if side A is in the numerator, then side B has to be in the numerator as well. You don't want to crisscross it, like if you do the angles on the bottom here, you can't do the angle in the top over here. They have to be the same. There's no like mixing and matching here. That's no good. So this is the parts of the law of sines that I'm going to use. A over sine A equals B over sine B. So I fill in the information I know. I'm trying to find side A, but I know angle A is 118 degrees. I know side B is 24, and I know angle B is 40. So here's my equation. Oh, Sorry. And there's really right now only one variable. All those other things are numbers. The sine of 118 is a number, 24 is a number. And I like to just work on the equation. Some teachers like to go into decimals at this point, but I like to just work my equation. I have a divided by the sine of 118, so if I want to have that a by itself and solve for a, I would multiply both sides of my equation by the sine of 118. And remember, you can manipulate that equation as long as you're doing the same thing to both sides. So this side would cancel or reduce, and we would be left with a equals 24 sine 118 degrees over sine 40 degrees. Our calculator can calculate that for us. In some calculators, you have to be a little bit careful to make sure that you put a parenthesis here after the angle that's in the sine. Same with down here. So just be careful about that. Sometimes that can cause issues. And so if you calculate that, you should find that the length of side A is 32.97 units. So that's side A. And let's try that one more time to find side C. So this time, the thing we're looking for is side C. So we'll divide that by the sine of angle C. And again, we know that partnership of side B and angle B, so we're going to use that to help us solve for C. So if I put in the values I know, angle C is 22 degrees, side B is 24, and angle B is 40 degrees. So again, if we're solving for side C in this equation, we would just multiply both sides of our equation by the sine of angle 22. And we get C is equal to 24 sine 22 degrees over sine 40 degrees. And again, we can calculate that using our calculator. If you're getting different answers than me, check the mode of your calculator. Make sure that you are in degree mode. And we find that the length of side C is 13.99. So in a nutshell, that's how to use the law of sines to calculate the length of an unknown side in the triangle. The law of sines can be a little bit more tricky when you're calculating an angle. I mean, there's some diagrams here that show you some different situations that come up. So I actually have a computerized one that I want to show you. It's a little bit easier to see, but basically we run into the situation of sometimes having information that won't create a triangle, or in some cases it might not be just one triangle. There might be more than one possible triangle formed. So we have to be a little bit more careful when we're finding an angle. I want to go through one first that's straightforward, and then I'll show you some cases that are a little bit more ambiguous. So this says calculate the measure of angle B. So we have a triangle here. We have angle A 40 degrees right here. So that means this would be side A because it's the one across from angle A. And angle B is up at the top of the triangle there. And so 2 would be the length of side B. So in this triangle, we're going to try to find angle B, and I like to start by writing what I'm trying to find, B. In the law of sines, the angles are always inside of a sine function. So sine B, in this case, is going to be over length B. You could set it up with the lengths on top again, but I like to always just put what I'm finding in the numerator. So I'm kind of flip-flopping it this time since I am finding an angle. And what we can use to help us find that in this problem is that we know the A's. We know the A side is length 3 and the A angle is 40 degrees. So I'm going to set the B's equal to the A's, sine A over A. And remember, if the angles are on top, they have to be on top, and in this case, the sides are on the bottom. So if we plug in the values that we know side B has length 2. We know angle A is 40 degrees, and we know that side A is length 3. So we're trying to get that angle B by itself, trying to solve for angle B. So we'll multiply both sides of our equation by 2. So we're left with the equation, the sine of B is equal to this whole thing, 2 times the sine of 40 degrees divided by 3. I'm going to go ahead and calculate that. 2 times the sine of 40 divided by 3 is equal to 0.4285. And again, that's just something I calculated using my calculator. 2 times the sine of angle 40 divided by 3. And now we've been practicing with trig, and we've been practicing finding angles, but sometimes people still forget how to figure out an angle if you know its sine. And we need to undo this sign here, so we use the inverse sign to do that. And so we have our calculator calculate that inverse for us, and it tells us that the angle B is equal to 25.4 degrees. So in a lot of ways, it's really similar to finding a side length. In this step, you have to remember that if you're trying to calculate B and it's an angle, you have to use the inverse sine function in this case to find that angle. Okay, let's look at another triangle. This triangle also has an unknown angle that we're trying to find, but in this case, there is, in a minute, we'll find that there is no solution. So let's do the calculations, and then I'll show you a picture of what's happening here. So it looks like from the information that is given to us, we have side B and we have angle B. So we can use that to help us find angle A. So our goal here is to find angle A. So I'll set up my sine equation. I'm trying to find angle A, so I'm going to have sine A come first in the top. That's over angle A. And we happen to know angle B and side B, so we're going to use those B's to help us find the angle A. Substituting in the values that we know into the equation, we know that A is 4. We know that angle B is 58 degrees, and the length of side B is 2.5. Solving this equation for angle A, we would multiply by 4, and we're going through exactly the same steps that we went through in the last problem. And we find that the sine of angle A is, and we can calculate this in our calculator, and the calculator says that it is equal to 1.3569. So again, when we're looking to find an angle, we use the inverse function. And when we do that, our calculator says domain error, or some version of that. What that error means is that there is no solution to this problem. So I want to show you a picture of this triangle that we're trying to make. So this is a triangle that has a 58-degree angle. So I have this diagram set up so I can adjust that angle. I could make it smaller, like 27, or I could make it larger. Our angle was 58 degrees. And we had the side across from that angle, so I'll go back for a second, 58 degrees. The side across from it is 2.5. So in the diagram here, I have set that at 2.5, and my diagram allows me to change it and adjust it, but we have it at 2.5 for our problem, and the other side has a length of 4. Now, our problem did not specify how big this angle is in between the 2.5 and the 4, and it doesn't specify how long this side at the bottom is that's shown in black. But you can see that if I have this angle 58 degrees set, and if I know those other two sides, there's actually no way to connect and make a triangle. If the side was a little bit longer, I could. That would be no problem. But my side is only 2.5. Or if the angle was a little bit smaller, we could also make a triangle. Oops, there we go. But again, we didn't have a 33-degree angle. We had a 58-degree angle. So this set of information that it gave us, just no matter where I move that side, it's just not long enough to connect and make a triangle. So that's the reason we got an error. We got an error because it is impossible to build a triangle with that data. Okay, let's go back. Well, not only is it possible that the data won't create a triangle at all, it's also possible that there are two different triangles. So I'm going to set up a diagram of this situation. We have angle A is 35 degrees. We have side A is 6. So those are across from each other. And we have side B is 8. So let's go back to my diagram and see if we can adjust that. Our angle is 35, so it's a little bit smaller than we had before. And the side across from it, the side that I have in green, is going to be 6. And then the other side is 8. I'm going to need to zoom a teeny bit here so it fits on the screen. It's much bigger. Oh. Okay. So the triangle, oh, sorry. Our sides are like this. We could easily make a triangle like so. Let's calculate the other angles in this triangle. So I'm going to go back here. We'll go through that same process. Let's find angle B first. We're going to use our knowledge about side A and angle A to help us calculate angle B. So it's going to be the sine of angle B over B equals the sine of angle A over A. And if we put in the information we know, our equation would look like this. And to solve for angle B, we would first multiply by 8. And we have that the sine of angle B is equal to 8 sine 35 divided by 6. Make sure you, when you're typing that in your calculator, you close that parenthesis there. And we get 0.7648, and that's the sine of angle B. So to find the measure of angle B, we have to do the inverse of that decimal amount. Oops. And we get that angle B is 49.9 degrees. And then it seems like a lot of work to go through and find that angle, and shoot, now we have to do it again for angle C. Not so though. Angle C is actually very easy to find. Angle C is just the third angle in the triangle. So our triangle maybe looked something like this. We started with 35 degrees. We just calculated that this one is 49.9 degrees. So we can just subtract those two angles from 180 and find that angle C is 95.1 degrees. So lovely. We found this triangle And we're feeling all good, but let's go back to our diagram for a minute. This is not the only triangle that has an angle of 35 degrees and a side of 8 and another side of length 6. What about, oh, sorry. What about this one? That's another triangle that has a side of length 8, a side of length 6, and an angle of 35 degrees. So there's actually this second triangle. What happens is your calculator really can't differentiate between the two triangles as far as the signs go. When it gives you that 49.9 degrees, it might be angle B, but it also might be the reference angle. And we talked about reference angles last time. It might be giving you this angle here is 49.9 degrees. It might be not angle B, but it might be a reference angle for angle B. So in that case, it's actually possible that instead of being 49.9, it's possible that angle B is actually 130.1. And again, I just use the idea right here of the fact that if the reference angle is 49.9, you could subtract it from 180 to get angle B in this case. So I'm going to go back to my, my problem here. So if 49.9 is actually just the reference angle, then angle B is actually 130.1 degrees. And in that case, so we have this second triangle. I'm going to go back to my diagram again for just a second. In this case, angle C up here at the top is actually a very, very small angle. And again, we can find that last angle by just remembering to subtract those two angles that we know from 180. So I'm subtracting the 35 and the 130.1. And we find that angle C is 14.9 degrees. So in this case, there are two possible triangles. Part of the reason that this ambiguity reference angles, and your calculator, when it's thinking about sines, it can't tell the difference between the sine of 49.89 degrees and the sine of 130.11 degrees. To your calculator, those two things, they're the same. So when you're doing an inverse sine, your calculator won't differentiate between the two. Okay, so we're going to go through and solve this triangle. It says right there in the instructions that this triangle is drawn to scale. So that information is really important, and we are going to use that information as we solve the triangle. When it gives you instructions to solve the triangle, that always just means that you are to find any missing sides or unknown sides and any unknown angles. So as I look at this triangle, the first thing I notice is that I have this angle here and the side across from it. So since our triangle is not labeled, I'm just going to call those A. So we have angle A is 38 degrees and side A is 32 inches. The other side I know is 40 inches. I'm going to call that B. And so that would make angle B this angle at the top of the triangle. We're going to find angle B first. So if I'm setting up my law of sines, I would start with that angle B that I'm trying to find. It's going to be divided by side B. And the ones that I know that are going to be helping me out today are my A's, sine A over A. If we substitute in the values that we know, side B is 40 inches, angle A is 38 degrees, and side A is 32. So we're trying to solve for angle B. So we'll multiply both sides of our equation by 40. So we get that the sine of angle B is equal to 40 sine 38 over 32. So if you calculate that, we get that the sine of B is equal to 0.7696. And again, if you're finding an angle, that's when you use the inverse. B equals the inverse sine of 0.7696. And so we do that in our calculator, and our calculator says your angle is 50.3 degrees. But remember, our instructions said our triangle is drawn to scale. So I look at angle B up there at the top, and I think, my goodness, does that look like a 50-degree angle? If I extend this line right here, you can see that it's actually definitely greater than 90 degrees. It's definitely an obtuse angle. So what this 50 degrees is it's giving us the reference angle. So angle B must be 180 subtracting that reference angle. So our angle B is actually going to be 129.7 degrees. And again, the only reason that I knew that it was the reference and not the angle itself was because my diagram is drawn to scale. So we found angle B to be at 129.7. That was probably the hardest part of the problem. It's going to kind of snowball from there. Angle C is going to be easy to find because we know that the angles in a triangle add up to 180. So if we subtract the 129.7 and the 38 degrees, it's going to give us the measure of angle C, which is 12.3 degrees. And we're almost done. We have one last part of the triangle to find. We need to find side C. Remember, when you're setting up your formula, you want to put the thing that you're trying to find on top. So we'll put side C on top, and we'll put those angles on the bottom, sine of angle C. And I'm going to go ahead and go back to the A's now to help me out, because I know that I know both of those. I know side A and I know angle A. So this time the sines of the angles are in the denominators. So as we substitute in, we know that angle C is 12.3 degrees. We know that side A is 32 inches, and angle A in the denominator is 38 degrees. If we're trying to solve for C, we're going to multiply both sides of that equation by the sine of 12.3 degrees, and that has solved C for us. We'll just let our calculator crunch those numbers. 32 sine 12.3, don't forget to end the sign, divided by the sine of 38. And that is equal to 11.07. And that was the last thing that we needed to find. We've identified all of the side lengths and we have identified all of the angles. So we have solved the triangle. Solving the triangle is kind of a long process. So I don't think there's more than, there's not a lot of those on your homework. I think there might be 2, I'm not sure. But I understand that it's a long process. So we're going to do just one last problem having to do with a little bit of modeling. Engineers actually use trigonometry. They use the law of sines. They use the law of cosines all the time to calculate different lengths. And so we're going to just try this problem. We have this reservoir, and it is supplying water to Springfield and Centerville. But right now, all of the water goes through an aqueduct to Springfield, and then it is pumped in towards Centerville. And they're thinking about building a direct aqueduct so that Springfield can just get its water directly. So our question is, how much pipe do we need? How long is that proposed aqueduct going to be? What's going to be the cost of building it? I mean, we're not going to calculate the cost, but we're going to figure out how long it is, which would help them calculate the cost of building it. So in this problem, it looks like the two that we know, the partnership, so to speak, is this angle and this side. So I'm going to go ahead and label that A. Angle A and side A. And the other side that we know, that 15 miles, is across from the angle at Centerville. So since Centerville starts with a C, I'm going to go ahead and call that angle C and this side C. Even though the thing that we're trying to find here is the aqueduct, which I'm going to go ahead and label B, we can't really start with it because we don't know angle B yet. So we're actually going to have to start by finding angle C. Angle C will allow us to quickly calculate angle B, and we'll have to use angle B to figure out side B. So we're going to have to actually solve the whole triangle. So the first thing we're going to have to find is angle C. Sine C over C equals, and the ones that we know that are going to help us out are the A's. So sine C over 15 miles is equal to sine 25 degrees over 7.5 miles. So solving for angle C, we'll multiply by 15. So we have sine of angle C equals 15 sine 25. I'm actually not going to write that out again. I'm just going to put it in the calculator. 15 sine 25, and we're going to divide that by 7.5, and we get 0.84523. Again, that just came from crunching that in the calculator. And to find that angle C, we are going to do the inverse sign. And we get for angle C 57.7 degrees. So we now know angle C, and we can calculate angle B very easily, especially if your teacher's handwriting is good enough to read. So those angles have to add up to 180, so we subtract 25, we subtract 57.7, and we find that angle B is 97.3. So now we just need to finish up finding side B. So we'll set up a little equation here. B over sine B. So I'm trying to find side B. And the ones that I knew from the get-go, the partnership that's going to help us out is the A's. A over sine A. Filling in the quantities that I know. Angle B, we just calculated to be 97.3 degrees. We know side A is, on our map, 7.5 miles. And angle A is last, and it's going to be 25 degrees. So to solve for the length of side B, I'm going to multiply both sides of the equation by 97.5. Wow, by the sine of 97.3 degrees. That will reduce. So in our calculator, we're going to put this quantity in. 7.5 times the sine of 93 degrees divided by the sine of 25. And we calculate that side B is 17.6 miles. So now that they know how long it is, they could decide whether or not their budget is enough to pay for the pipe that they'll need for the project and the labor. And we are done calculating triangles for today. So we're almost done with Unit 8. We are next time going to work on a law called the law of cosines, and then that's it. We'll be reviewing. So if you need some additional help on this, please come in. Your teachers would love to help you. And just don't try not to get behind because the test is really going to come up soon. So that is all. Thank you.